Yes. So in the very first unit, we'll be dealing with the very first topic, which is state different steps involved in problem solving. So in this particular topic, we'll be primarily focusing on what is a problem and how can we solve it. And whatever steps we are using, step by step, we will write certain procedure to solve a particular problem, right? Whatever steps we are writing, those steps are basically called as algorithm. And if you want to solve any problem, if you are trying to solve it, there may be multiple ways in which you can solve. And which of the way which you have written is the best one. If you want to determine that particular quality, you need to get to know what are its characteristics. So based on the characteristics, you will get to know which algorithm is a good one, which one is not a good one. And then we'll be learning whenever we want to write an algorithm, what are the basic steps that are needed to write that particular algorithm. Then using those steps, we'll try to develop certain algorithms for simple tasks. And then algorithms are basically natural language, like English language. Step by step, you will write. In the first step, you want to do something. In the second step, you want to do this thing, and then third step, and then fourth step, so on. But if you want to put it on a paper and represent it in front of someone else, then you want to depict it, draw it. That drawing format, the diagrammatic format of your algorithm is nothing but flowchart. So we'll be trying to learn what is a flowchart, and we'll be trying to learn what are the various symbols that are used in this particular flowchart to be developed. Next, we'll be trying to have some flowcharts for the algorithms that we have developed here. And along with them, we'll try to have a differentiation between what is an algorithm and what is a flowchart. So basically today I'm primarily focusing on finishing the first 7 topics here, and let us begin. So what exactly is problem solving? Before we go for what is a problem, uh, let us first get to know what is a problem. A problem is any situation which becomes complex and you want to simplify it and you want to get a result. So a problem will be in simplest terms like calculation of summation of two numbers like 10 plus 20. It's very simple. We'll get to know its answer as 30. We as a human being, we can get to know it. But what about a computer? You cannot expect a computer to tell it very far so easily. We need to tell the computer 20 is a number, plus sign is for addition, and 30 is another number. Add 20 and 30 and give the result, store it into another place called as result, and that result value is to be displayed out. So there is a lengthy process which we have to adopt. So whatever problem is there, the problem solving is a methodological approach or a set of techniques. Basically, it is a methodical approach or a set of techniques to find right solution for a given problem. And whenever you're trying to do with the problem solving, first thing that you need to get to know is what is the problem. You need to precisely identify what exactly is the problem, and then you need to come up with a solution in terms of a program or a software for that particular problem to be solved. So, keeping in these points in our mind, let us try to get to know what are the steps required for solving a problem. This is an important question. The first step that you need to get to know whenever you want to solve a problem is what exactly is the problem. You need to analyze the problem. Then, after analyzing the problem, you need to develop an algorithm, a procedure in order to solve that particular problem. you will write step 1, I will do this thing to solve this problem. In step 2, I will do such and such thing to solve that problem. And step 3, and so on and so forth. Then after writing it in a brief English format, you'll try to convert that particular algorithm into something called as coding. Coding is nothing but exactly the program that a computer can understand. So coding is a terminology which is used for computer programs actually. Whenever you start writing any program, you will be called as you are doing a coding. Okay. So these algorithms are plain English format, but plain English cannot be understood by the computer. Computer needs to be communicated, to be spoken in terms of its own language. So we'll convert these algorithms into its respective language, and that language algorithm is called as coding. Once we have written the program, we'll try to test it and debug it. If there are any errors, we'll try to resolve those errors, and that resolvement of errors is called as debugging. Hope this slide is clear for everyone. Now let us more in detail. Whenever we try to analyze, we need to have a very clear-cut understanding of what exactly is the problem. And whenever we are trying to understand what exactly is the problem, we need to list up the basic small sub components of the problem which we can tackle easily. For example, if tell you you need to appear for an exam. So writing an exam is a problem now for everyone. Now, to write the exam, you will do certain small tasks. Like, for example, you will prepare your own self with all the subjective matters to write the exam. And once you are done with preparation of your materials, then you will try to approach to the examination center in this step 2. And in this step 3, you'll try to write the exam. And in this step 4, you'll try to get to know what is the result of your examination. So basically there are four components here. The four components are preparation for your exam, then appearance in the exam hall, writing your exam, and then getting the result. So whenever you are trying to understand clearly what exactly is a particular problem, you will try to get to know what are its internal principal components. Now, once you are aware of what are the internal principal components, you will get to know what are the functionalities of those components inside it. Those functionalities will be like, for example, when you are preparing for your examination in this step 1, you are trying to get certain things, certain materials, notes, PPTs, and videos, and all those things, and you are trying to collect it, understand those materials, and grasp that knowledge. These parts are nothing but the functionalities. And once these components and functionalities are known to you, you need to get to know, okay, these are the things that I have to tackle up as the task in solving the problem. Now, what are the requirements, initial things needed to do up with this task? Those initial things that are needed to do up the task is nothing but inputs. For example, you are preparing for the examination and you are going for writing the exam. What are the inputs in that? First thing, you should have the knowledge of this subject. Second, you should have proper utility, your pen, pencil, eraser, and all those different tools which you need to write the examination. You need the paper, you need the exam pad. And once all these things, inputs are available, with your mind as the processor, you'll try to write that particular answer script. And after that, that paper will be evaluated and the final output will come as the result. So by analyzing a problem, we would be able to figure out what are the inputs that our programs should accept. and the outputs that it should produce. In the second step, which is developing an algorithm, analyzing, you will try to put it in on paper. You will basically document the step 1, step 2, step 3 that are needed for solving a problem. And in simplest terms, algorithm is nothing but a set of exact steps which, when followed, solve the problem or accomplish the. So basically, algorithm is nothing but a set of exact steps which, when are followed, those steps which are followed, solves the problem which we are trying to tackle. And that particular problem is nothing but our task. So whenever we start writing a solution for a particular problem in terms of steps, we'll first write roughly that, okay, these are the steps. Then after writing them roughly, we'll try to make them as fair notes. And while making fair notes, you will come to certain points will be there which you don't think are necessary, and certain more points you will find that these things we missed out. So you'll try to refine out that particular algorithm into more genuine algorithm. And once that refinement is done, you will put that particular step-by-step procedure in terms of something called as algorithm. So basically, algorithm is nothing but the solution which is represented in natural language, plain English language. That's nothing but algorithm. And for any given problem, there can be multiple ways of solving it. For example, if I ask you add 10 plus 20, you can first write 10 above, then 20 below 10, and then add 10, 20, and write the result as 30. Instead of that, if I want, I can also write 20 above and then below it 10 and then write the summation as 30. The result is same, but there are multiple ways of doing it. So there may be more than one algorithm possible for a given problem. Which one is best? We need to understand it, and that can be brought up only by looking into the characteristics, which we are going to learn later on. Okay. So on to the third step in problem solving. The third step is nothing but coding. Basically, whatever algorithm we have written, that is there in plain English. Now you have to convert that plain English into a format which is understood by the. Whenever you try to convert it, you need to make use of a language which the computer understands. Computer doesn't understand English or Hindi or Urdu or Telugu. We need to speak in terms of its language. And one of the best language, basic language, which is available is nothing but C language, which we are going to learn in our subject. Okay. After that, we are going to test a particular problem, solution which we have developed. Okay? And then we are going to, so if the program works fine, it's well and good. But if the program makes any errors, then the particular errors are to be removed or resolved so that we can get our expected result.
Sir, your voice is not clear, sir.
Is it fine now?
Yes, sir.
Yes, sir.
Sir.
Okay. Okay, good. Thank you. So basically, whatever program we have written, we will try to test it. And while testing, if we get any errors, we'll try to remove those errors. And that resolvement of errors is nothing but debugging. So debugging is the process in which you will try to remove the errors so that the program which we have written can give us our expected outputs. Okay. So the errors are basically of two types. One is syntactical error, second is logical error. Syntactical error is something which a computer can detect. For example, when I'm speaking in English, I may say for an instance, I'll say like, "Hi, how are you?" Instead of telling "Hi, how are you," I'll tell "Are you how?" It doesn't make any sense. right? We need to follow certain grammar whenever we are speaking with each other, right? Same way, when we are speaking with a computer, we need to follow certain grammar, and that grammar is called as syntax. And that syntax, if it is not matching exactly what is needed, then the computer picks that as an error, and that error is called as syntactical error. But sometimes the syntax will be correct, but logically that particular statement will not have any sense. For example, I'm taking a class now and I'm just telling a rubbish sentence in between. I'm not coming today. It doesn't make any sense. I have spelled I'm not coming today exactly syntactically correctly, but is it having any logical point in it? No. So your program may contain two types of errors. One is syntactical error, second is logical error. If you think that syntax is correct, everything is correct, then also you need to get to know what are the logical errors, and if there are any logical errors, then you need to resolve them also. And while resolving these errors will be resolved in a phase called as testing. Okay, so when you are trying to test a particular software or a program, you will try to test it individually. One piece of program doesn't work. For example, you have done with MS Office. MS Office was containing MS Word, MS PowerPoint, MS Excel, and MS Access. Four different components. All of them combinedly together were considered as one single software, right? But if you take MS Word itself, MS Word was having certain utilities, tools for making formatting of text, certain tools for printing, certain tools for layout management, and all those different functionalities. Basically, each functionality is an individual program. So one program will not usually be called as a software. A software is a collection of multiple programs. So what you will do in testing is you will take up one program, try to test it. That is called as unit or component testing. And then once individually each program is correct, you'll try to put all those programs together and you'll test it again. That's called as integration testing. And once even the integration testing works, you'll try to install it onto a system and then test it out. Is it working perfectly or not? If it is installed on a system and still it's working, then you will try to give it to the user for whom you have developed that particular program and check whether the user is satisfied or not. That's called as acceptance testing. So there are four different types of testing. Basically, unit or component testing, integration testing, system testing, and acceptance testing. Okay, so let's move ahead. Let's get to know what are the various characteristics for an algorithm using which we can get to know whether an algorithm is good or not. Before we get into that particular thing, talk about what is it. Algorithm is nothing but a set of exact steps which, when solves a particular problem or accomplishes the required task. Simple definition. Okay, this algorithm is basically a concept which was brought in by a person called as Khwarizmi. This Khwarizmi was a person who was actually a Arab Persian astronomer, and his full name was Abu Abdullah Muhammad bin Musa al Khwarizmi. He was nicknamed called as al Khwarizmi, and the Latins, the Spanish people and Italian people, they don't say fa, they say ga. So it became as algorithmy. So from that algorithmy, the term algorithm came up. So anyway, whatever may be the historical perspective of it, the question that may come up in the examination is like, who developed algorithm? It's Abu Abdullah Muhammad ibn Musa al-Khwarizmi. So let's talk about what a programmer does. Programmer writes a program to instruct the computer to do certain tasks as desired, and the computer then follows those steps written in the program code. Basic point. And there are various things which we need to know. First one is the characteristics. When we are writing an algorithm, what are the basic things that we need to keep in our mind? When it comes for characteristics, this is very important question for your examination. The first characteristics is precision. Precision means how many steps are needed for writing your algorithm. For example, if I say calculate addition of two numbers, step 1, read the first number. Step 2, read the second number. Step 3, compute addition of step 1 and step 2 numbers. Step 4, print the result. Right? I'm taking 4 steps to resolve my problem. But can there be any solution with just 2 steps? Can it be done with just 2 steps? If those steps can be precise enough, can be as small as possible, then that precise algorithm is considered as the best one. Is it clear? Then the second characteristics is about uniqueness. Each step that you are trying to do should be unique. It should not be repeatedly done multiple times. Okay, so each step should be unique. Plus, your algorithm should not be composed of, like, for example, 90,000 steps. It's not an algorithm. Your number of steps that are needed to resolve that particular problem should be finite. There should be an end to the number of steps. Number of steps cannot become infinite in that one. And then the other characteristics is what type of inputs you are going to take and what is the end result output that you are going to generate. So basically, there are for 5 characteristics. First one is precision, second is uniqueness, third one is finiteness, fourth one is input, and fifth one is output. I hope these characteristics you will memorize them. It's very important question, and you need to understand them very clearly. And whenever you are trying to write an algorithm, you should keep in your mind what is the input that you are going to give to your program, what is the processing or computation that is to be done to get the desired result, and then what is the expected output that you are trying to take. Whenever you are trying to develop an algorithm, you need to follow 5 different steps. This is again an important question for you. The 5 steps are: obtain a description of the problem. Second is analyze the. Third one, develop a high-level algorithm. Fourth one, refine the algorithm by adding more details. Fifth one, review the algorithm. These are the 5 steps that are needed whenever you are trying to write an algorithm. Okay. In a glimpse of what we have now, a computer is nothing but a tool which is used to solve a particular problem. But that tool cannot be running by itself. It has to be given certain instructions to make it to be run. Instructions are nothing but the program. It's a set of instructions to a particular computer. Then, whatever program you are trying to write, that program is in a language which is understood by the computer, right? But that particular language cannot be understood by a normal person. To be made to be understood by a normal person will write it into a plain simple English language, which is nothing but algorithm. So algorithm is a plan for solving a problem, basically. And then whatever person is trying to do, a person will try to design an algorithm and translate that particular algorithm into a computer program. So here is one simple example of what algorithm looks like. For example, to calculate square of a given number, the step one which is needed is take the input a number and store it into a variable called as number, NUM. And then in this step two, you will compute num, which is basically containing whatever number you have read here, and you are trying to multiply it with itself. And then store the result back into another variable called as square. Basically, variable is nothing but a name given to a memory location where you will save certain value. Okay. So in step one, you are trying to read, input a particular number, store it into a variable called as num. And then in step two, you are trying to compute num into num, which is basically number value. For example, let us say 2 into number value, which is 2 again, 2 into 2, and you are storing that result 4 into a variable called as square. And in then step 3, you are basically trying to print that particular square value. Now that was regarding the algorithms. Moving on, when you want to show that English language text in front of a normal person, the person will not have any knowledge about that particular, what is this variable, this num into what is this asterisk. A normal person doesn't has any knowledge about it. Basically, when you become a developer, CEO of the company or the manager of the company will not be aware of these terminologies. So you need to draw it and explain them in the simplest format. So there are various ways in which we can represent an algorithm. The simplest format is flowchart. And another way of representation of algorithm is there, which is called as pseudocode. This code is very difficult. It's also very similar to algorithm, but it's one of the ways of representation. So there are two common methods of representing an algorithm. First one is flowchart, second is pseudocode. In case of our syllabus, we are concentrating only on flowchart. So let's begin. Just give me 1 minute. Okay. So both of them, flowchart as well as pseudocode, they can be used for representation of algorithms, but we should keep in our mind that whichever way we are trying to use, whichever method we are trying to use, it should showcase the logic of the problem solution, should show what is the logic behind this solving of the problem, excluding, not going into detail about any implementations. Okay, because we are trying to represent it to a person who doesn't has any knowledge about the computation. So that particular showcasing should be done, basic logic of solving should be known, but no internal implementations should be given. Secondly, it should clearly reveal what is the flow of control step by step. Step one, after step one, step two, then after step two, step three will come, then after step three, step four will come. It should give the flow clearly how that control will go on till the execution of the program is done. Okay, so in simplest terms, a flowchart is a visual representation of an algorithm. And whatever flowchart is there, it's nothing but a diagram composed of boxes, diamonds, and other shapes. And basically, those boxes, diamonds, and other shapes are connected with arrows. Here diamonds are not the jewels, it's basically this symbolic notation which is used for decision making. Okay, what is the name of each symbol? I have clearly written here, and what are its functions? Why do we use them? I have written it here. Please go through them. Okay. Now, one simple representation, we have learned algorithm to find square of a number, right? Which I have written it here back again. Step 1 was input a number and store it into a variable called as num. Then step 2 was compute num into num and store it into a variable called as square. And then step 3 was to print that square value. The same algorithm can be depicted in a flowchart format in this way, where we are writing the first step as start. Second, we are taking the input into variable called as num, and then we are just writing square is equal to num into num, and then we are writing this next step to print that square value and then finally stop. Do remember, every algorithm should have a start and a stop. In between, you need to process something. Whenever you are doing any input or output operation, it will be represented with a slanted rectangle, which is basically called as parallelogram. Okay, when you are computing certain things, doing certain tasks, then that is represented in a rectangle, straightforward rectangle. It's not tilted. Okay, so whatever inputs are there and outputs are there, you'll represent with a slanted rectangle called as parallelogram, and whatever computations are done, you'll represent by using a rectangle. If you recollect back, this symbol, which is the called as, you're trying to make a decision. For example, from the previous step you are coming in, you're trying to make a decision here, yes or no. If yes, go into this direction. If no, go into this direction. So basically, there are various things we'll come across later on. For each problem, we'll try to develop this algorithm and then flowchart and then write the basic thing I have given to you. Now, there is a small slip test for you. You need to write algorithm to display sum of two numbers entered by a user and then represent the same using a flowchart. This is the first question in the slip test. Second one is, you need to write an algorithm to calculate perimeter of a rectangle, represent the same using flowchart. So simple parts. Do refer this particular slide. You'll easily be able to write it. You need to upload these two things in the Google Classroom. Do remember this thing. And now coming on for differentiation between what is an algorithm and what is a flowchart. Basically, algorithm is a step-by-step procedure to solve a problem. Flowchart is a diagrammatic representation containing different shapes to show the flow. Algorithm is complex. It requires knowledge about what is a number, what is a multiplication symbol, what is the addition symbol, and all those steps. Flowchart is easy to understand. An algorithm is plain text English language, but in flowchart there are certain symbols. You need to know what symbol is used at what for what representations. This is a small thing which you need to adapt here. Algorithms are easy to debug. If there is any error, you can easily pick up in the algorithm, but in flowchart you will be not able to get to know can there be an error in this step or not. Algorithm is difficult to construct, whereas flowchart is simple to construct. Algorithm does not follow any rules. Plain English sentences are there. Flowchart follows certain rules. Which symbol is to be used for what particular operation? You need to be very particular about that. Algorithm is pseudocode for the program, whereas flowchart is just a graphical representation for that logic. So by this, I want to finish up our class now. If there is any doubt for anyone, they can raise that particular topic. They can just simply unmute their mic and speak with me. Just waiting for 2 minutes. After that, I will be finishing up with the class. Is there any doubt for anyone in this particular topics?